Quick, graph one period, y equals 3 times the cosine of the quantity, 1/2 x plus pi over 3 plus 2, by hand. This is part of the family of functions series. You will need paper and straight edge, and we suggest you create grids similar to the ones at the right as needed, and as always, press pause as needed anytime during the video. Notice that we're only asking to graph one period of this complicated cosine function. First way we're going to do this is to analyze which parameters affect the y values. And that would be the 3 times and the plus 2 outside the function. So we're going to multiply each y value by 3 and add 2 to each y value. By the order of operations, remember we multiply first and then we add second. So let's look at the y values of the points of interest. 3 times the y value plus 2 is going to be what we're going to do here because of these two parameters. The maximum normally is at y equals 1. 3 times that 1 plus 2 is equal to 5. So our maximum is going to be at 5. Points of inflection normally are at y equals 0. But if we multiply that by 3 and add 2, we get 2. And the minimum normally at -1, multiply that by 3 and add 2, we get, again, -1. So here's a quick summary down here where the max, the point of inflection, and the minimum are for the y values. Which parameters affect the x values? Well, that would be the 1/2 here and the plus pi over 3 inside the parentheses, inside the argument. Since the beginning of the period normally starts at x equals 0, we're going to set this entire argument equal to 0 and solve for x to see where this actually starts one period. So I took 1/2 x plus pi over 3, set it equal to 0. Algebraically, we'd like you to pause to do this. So I multiplied both sides by 6 to clear out the fractions, subtracted 2 pi from each side, and divided each side by 3. So at x equals -2 pi over 3, that is when the first wave or period begins on this graph. The end of the period normally ends at when the argument is equal to 2 pi, so we're going to set that entire argument equal to 2 pi and solve for x. Pause to do so. So I'm going to multiply each side by 6 again. And I'm going to end up with 3x plus 2 pi equals 12 pi. Subtract 2 pi from each side and divide both sides by 3. And so the end of one period is going to be at 10 pi over 3. Press pause as needed to be able to decide what units you're going to mark off on both axes. So we're going to suggest marking every pi over 3 along the x-axis because of the beginning and the end of the period. We're also going to suggest marking off y equals -2 to y equals 6 in ones along the y-axis. So pause to set up your axes using this information. So here we have it, marking off every pi over 3 here, and from y equals -2 to y equals +6 along the y-axis. So putting all of this together, all these clues together, so to speak, I'm going to draw dotted horizontal lines at the maximum, the points of inflection, and the minimum, the points of interest. Y equals 5 I'm doing in blue to set it off. Points of inflection at y equals 2 in orange. And then at the minimum y equals -1. So I'll have the graph fit in between those dotted lines. Recall the graph of y equals cosine of x, one period of that. It starts at a maximum. So normally that would be at 0, 1, but for our purposes, that's going to be at -2 pi over 3, 5. So that's where we'll start there, and we'll plot a point there. The end of the period is normally a period later, and it's 2 pi 1, but this one is going to end at 10 pi over 3, also at a maximum 5, so we'll plot a point there. Halfway in between the two maxes is a minimum, so halfway between is going to be at 4 pi over 3, right here is halfway between, and it's a minimum, which is -1. Halfway between max and min is a point of inflection, and so halfway between, that's going to happen at pi over 3, and then it's going to be at pi over 3, 2 instead of at pi over 3, 1, because points of inflection along y equals 2. And similarly, the other point of inflection will be halfway between at 7 pi over 3, comma 2. So pause is needed to catch up here. Connect the points as a cosine wave, part of a frown, concave down, smile, concave up, concave down. And here it is much more smooth. We're waving along there. Equivalent forms to this equation, we could factor out the 1/2 in the argument, and then it'll be 1/2 the quantity x plus 2 pi over 3. And we do that because the phase shift is now left 2 pi over 3, and we can see that that's the case right there. At -2 pi over 3, it starts the cosine wave at a maximum. And the coefficient 1/2 is inversely related to the period. So if I take 2 pi and divide it by the 1/2, or multiply the reciprocal 2, I get 4 pi, and that is the period of this. So there are a couple different ways of approaching how to graph this complicated cosine function. Pause is needed. Now you try one, graph one period of this cosine function here, and I'll give you a hint, you will need to change the units, so pause to do it and then resume when you're ready. So here is the graph, what it looks like, highlighted where the max, the points of inflection, and the minimums are, where the beginning of the period is, where the end of the period is. So I'll leave you some time here to study that, and good luck.